Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try out a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode today, that's Linode, and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your own home. Go to pythonpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host, as usual, is Tobias Macy, and today I'm interviewing Davide Spadini about PyDriller, a framework for mining software repositories. So, David, can you start by introducing yourself?
Yes, thank you very much. Thank you for having me. I'm David. I'm a PhD student at Delft, University of Technology in the Netherlands, and a part-time researcher at SIG, Software Improvement Group company in Amsterdam. And I actually just finished my PhD like 2 months ago. I'm in the thesis writing phase, and in the last 3 months, I've been working as a software engineer intern at Facebook. And yeah, as you said, I'm the author of PyDriller.
And do you remember how you first got introduced to Python?
Ooh, yeah, that's a long time ago. I was first introduced to Python. I think it was high school, and I did my high school in software engineering / computer science, and they were teaching me like algorithms. And there, they taught me first Pascal and then Python, and then we moved on to Java and C. But then I really started developing Python, I think, when I was in my bachelor, so around 10 years ago.
And as we mentioned, you created the PyDriller framework as a means of mining information from software repositories and version control systems that house them. So I'm wondering if you can give a bit more of a description about what the PyDriller project is and how it got started.
So, well, as you said, PyDriller is a Python framework for Git. So we all know Git is very famous, very popular, very powerful. And especially in the research community, what we do with Git is often we go over the history of a project, the history of, developers and how they write files, etc. And to do so, it's often not enough to use Git from the terminal. It's just quite complicated to write, one line of command at a time. So what we generally do is we use Git in our preferred programming language, that is Python, Java, whatever people want to use. And so people created frameworks for Git in all the major programming languages. And for Python, there is Git Python and there is also PyGit too. However, these tools are also quite complicated as they are like a 101 mapping of Git just in Python. And what PyDriller tries to do is it uses some functions that the researchers usually do. So what we generally use of Git is we read information. So as a researcher, as I said before, we go over the history of a project and we just extract information. We almost never commit and push and merge. We just read. So what PyDriller does, it's just simplified this reading operation extremely, and you can do reading in just one or 2 lines of code.
And you mentioned that there are a number of other frameworks in other languages, and I'm sure that there are probably some others in Python as well. I'm curious how the PyDriller framework differs from some of the other ones that are available and what motivated you to create it rather than use something that already existed.
So the reason why I started PyDriller in the first place is I was helping my advisor in teaching the MSR course, Mining Software Repository course here in Delft. And we were teaching to students how to use Git and how to go over the history of a project, etc. And they were often coming to us and say, okay, but is there a tool? Is there a better way to do this in Python? And we always said, well, no, there isn't. Sorry, you just have to call Git as a process from Python, or you have to rely on Git Python, PyGit, and other tools. At the 10th time the students came to us, I said, okay, well, let me build it for you And there was a similar project written in Java. It was called the RepoDriller, and it was from a good friend of mine. And so I took this idea and I just did it in Python, and then then it just became popular and it exploded, and I just put so many features on it. And I think the difference with other tools is that what PyDriller does, those less feature, as I said before, PyDriller doesn't map. It's not a mapping 101 of Git. So in PyDriller, you cannot, for example, push or commit or add files to a commit or all these kind of things. You cannot do. For this, you have to rely on Git or other tools. However, for reading operations such as give me all the commits of the last year of this on this branch of this author, then in PyDriller this is just one line of code. So that's I think that it's the big advantage of PyDriller, I think, and the biggest difference with other tools.
And in terms of the types of research that you would be able to perform by mining these software repositories, what are some of the topics that you're looking to cover and the types of information that you're able to discover by digging through the history of a Git repository?
There are so many things that we can do research on by looking at the history of a project. So there is even a specific conference of software engineering. It's called MSR, and this conference it's every year. It's one of the top software engineering conferences in the world, and in there are just MSR studies, so just studies that look at some kind of mining. And so mining software repositories is a pretty broad, a pretty vast topic. It doesn't only mean mining code. So we often think as a software repository as a Git repository, but it's actually not. A software repository can be anything containing software related information. For example, we can emails or bug tracker tools and everything that contains some kind of software information. So PyDriller only focuses on Git, but coming from, by analyzing history of projects, we can get so much information. For example, all the path about defect prediction. So trying to detect whether the file in this commit contains a defect or not based on the history of that file or on previous, like on similar kind of code changes of the past. So this is something that many people do, defect prediction. But yeah, or we can also, there is also a line of like how to transform, how to improve code review. And so how to allow developers to do code review in an easier way and how to detect at code review time that there are problems. And all this is done like analyzing the history of all the code reviews, etc. Yeah, so pretty much everything you can extract. So Git is it's a very big source of information. So, and we have to be very careful because, there are many people work on those projects and they contain names and emails and this kind of thing. So we have to be quite careful on how we want to publish those data and those results. But otherwise, it contains an enormous amount of information.
And so, with all of the information that you're able to pull from Git, as far as things like the authors, the change sets of the code that's being committed, all of the timing information, what are some of the ways that that collected information might be used in some of the research projects that you've been involved with to take advantage of all the information that's stored in these repositories?
A lot of empirical studies on, for example, like quality of the code. So can we somehow identify files that have poor code quality, production files as well as test files, and we can even go deeper and analyze at method level and maybe trying to predict whether this has will have some kind of impact in the future. And this is all done by like analyzing in the past and trying to predict the future and whether this file will contain a defect. Or like we studied test smells, which are like let's say test design issues. And in there we went into the history of projects and see whether these design issues were present and what was their effect on quality. So these are some of the studies we've done, but as I said before, sky's the limit. I mean, the history, and it's full of information. So all the branch of defect prediction on code review is about history of projects. So yeah, pretty much anything that we can learn from the past to try to improve the future is done using like these kind of studies.
And in addition to what's stored in the Git repository itself, there are also these collaborative platforms such as GitLab and GitHub that layer on additional things like conversations within the code reviews and issue tracking and things like that. I'm wondering if you've done any work to integrate those additional sources of information with the content that's stored in the repository itself to be able to gain any deeper insights or do some research that covers ground that isn't directly related to the specific code itself, but the ways that people are interacting around the code.
Definitely. That's a very good point. We generally do this, and we generally use multiple sources of information. So when we study something about code review, we generally look at the files that changed during code review. And I mean, code review is just a fancy way of saying it's a commit that is there to review, but it's a commit. So there are files changed there. There is source code. There are diffs. So there are a lot of information that we can analyze. So how to become more effective in code review at the end becomes, okay, let's analyze the commit and let's see whether we can extract some kind of information, whether we can improve, how we can support developers in doing code review. So for example, we study whether the position of the test files within the code review, whether it is before or after its production code, it has an impact on like the time required to do the code review. And this is all done looking at the history and doing experiments and changing how GitHub presents the file in which order. So yeah, definitely we look at many different sources of information. As you said before, backtracking tools like Jira, we also look at those. So, generally, each commit has a bug ID that you can refer to. So we can look at like the severity, the type of the bug, etc. And again, then we go back in the history and we see whether it had some kind of impact and whether we can avoid this to happen again in the future. Yeah, so definitely yes.
And in terms of the tool itself, as you said, using the command line directly can be quite cumbersome and isn't really conducive to being able to do any sort of in-depth analysis. And I'm wondering, what are some of the additional metrics on top of Git itself that you're able to extract using PyDriller and some of the capabilities that you've built into it?
Yeah, so by default, PyDriller is a Git framework. So we only extract information that are present like in the Git repository. However, we saw that many users were using PyDriller together with some other tool to perform some static analysis. For example, with PyDriller, you can get the source code of the file in that specific commit. And then once you have the source code, maybe you want to perform some analysis on it, like calculate the complexity of the method that changed in that commit before and after the change, etc. So at the end, what we decided to do was to make use of another tool, a static analyzer tool. It's called Lizard, and Lizard is a tool that can calculate code metrics. So we integrated the tool inside PyDriller, and now we can, for example, for each commit, for each file changed in the commit, see the complexity before the change, after the change, and maybe compare them. So you can get, as we said before, let's take the commit at that code review, and we see whether, for example, the change improved or decreased the complexity or increased the complexity. We can do kind of very fancy things. So yeah, other than Git information, we now provide code metrics information, and yeah, then we stop. Then everything else it's then on the user side.
In terms of the implementation of PyDriller, how did you go about developing it and determining the overall structure and the API to make it easy to use and accessible, particularly for people in the class who aren't necessarily expert programmers?
Yeah, so I think for this particular case, so I try to be as Pythonic as possible. And Python is really an amazing programming language, and it's so easy to read. So, and the same should apply to all frameworks written in Python. So what I wanted to do was like just simply focus on simplicity and abstract from the user all that Git complexity, because Git is really complex, and just PyDriller handles that. So, someone should be able to just write for each commit in the repository and for each file in that commit, do something. I mean, that was like my main goal. 2 lines of code, it should be it. This is it. So at the end we managed, and that's what we have done. So now with just 2 lines, and you can do all this. And then what we decided to do is, so these kind of studies, research studies, are, well, we often need to customize like inputs. So for example, we generally, at least, don't analyze the entire history of a project. A big project like Hadoop with hundreds of thousands of commits, it's going to be very hard. So what we generally do is we customize it a lot. So for example, we only get commit of on a specific branch, or maybe from a date to a date, or only commit on that particular file, or only commit of that author, etc., etc., etc. So another priority for me when I built PyDriller was, okay, it needs to be highly customizable, because yeah, users, and in these studies we really put a lot of filters in at commit level mainly. So, and this in Git is possible, but still it's like in the documentation buried somewhere. So in PyDriller, all this is just 1 line of code. So you just put like for commit in the repository, and you put there all the filters you want to apply, and we have so many, and you just enter, and then that's it. It does it for you.
And when I was looking through the documentation, I noticed that one of the base interfaces is to open up a repository with this class object, then be able to iterate over the commits. And I'm curious how you handle things like branches and ensuring that you're able to handle things like dead end branches that never merge back into the trunk or things like that, and just some of the strange complexities that can be built into the workflow of how somebody interacts with Git and the ways that they handle things like tagging or multiple branches or merge commits versus rebasing versus squashing and all of that.
Yeah. So that was a lot of issues opened on PyDriller, to be honest. So when I started, I was mainly handling like the simple cases. So few branches and few merge commits, and if the merge happen, it's only 2 branches, no more, and etc. etc. And then I think that the community just started to work on it, and they really helped me a lot. And I think overall, I mean, when I started 3 years ago, I thought I knew Git, and I soon discovered that I didn't. And even now, I think I still don't know that much. It's just, I mean, there are so many cases to consider, and there is like one issue open, I think, every couple of months, saying, yeah, but if you open a branch like this, and then you commit, but then you amend, and then you rebase, and then PyDriller breaks, and I'm like, okay, let me learn something new about Git that I didn't know before. So overall, I think now it's pretty solid. I think we are able to handle like many cases, and it should be like 99% of the cases that you mentioned before. But still, so another thing that it really simplifies the PyDriller is that we only perform reading operation. So we never write, and actually almost never, because I let the user do checkout and reset. It's not really writing, but it's, let's say, changing the state of the repository. Those are the only two kind of operations that I let the users do. Otherwise, we never perform writing. So by reading something, it's often, I mean, it's hard it's not impossible, but let's say it's hard to report something wrong. If a commit is in that branch and that branch, well, it is. I mean, if Git says that it is, it is. So I just report it. So yeah, I think by not changing the state of the repository, we really simplify a lot PyDriller. And overall, I mean, again, as I said before, if you find an issue and a case that I didn't cover, well, GitHub is there. Just open the issue, and I will try to read the documentation and try to learn something new.
For being able to write the tests for it, I noticed that you have a zip file of some handcrafted repositories to be able to cover the different scenarios that you're trying to address in the tests. I'm curious what you have found to be some of the most complex or challenging aspects of being able to write meaningful tests for a framework that is trying to address something as complicated as Git, as well as the challenges of a repository into the state for being able to give a test case for those assurances.
Yeah, so I think so. One of the most complicated things was to handle different branches and merge commits. So that was definitely something that I had to put a lot of effort on it. And you check out on a new branch and you modify a file on the other branch, and then on this branch, then you merge, and then you have conflicts. And PyDriller should always return, I mean, the Git side of the view from Git side, let's say. So all those particular and kind of corner cases scenarios, then yeah, I had to manually create them, and thinking about a lot of them, it was quite hard to try at least to cover. I mean, of course, you cannot cover 100% of the cases, but many of them that was really hard. But otherwise, I think most of the handcrafted repositories I have there, they are pretty simple, and they are mainly, for example, a repository with two branches, and this repository is used to filter like all the commits in a specific branch. And I mean, this is a very simple scenario, and the repository is really simple. I think it gets complicated only when we have merge commits and conflict files, etc., and then it's a bit hard to understand. What was the other question? I don't remember.
Just the issues of writing tests to be able to cover representative samples of what a Git repository can look like, as well as building a repository that represents those different states that you're trying to test.
Yeah, so I think, again, as I said before, PyDriller is community driven. When I started, I think I had something like 4 or 5 repositories, and already now I have like 12 or even more. And the only reason why this happens is that the community, someone opened an issue saying, look, if I check out this branch and I modify that file, and then I check out the other branch, and then this happens and this happens, you don't cover the case and you report a wrong result. And then what I generally do is I recreate manually a simple case scenario of that problem, and then I will create a test, and then and then this repository will become like part of PyDriller, because from there it will always stay inside. So yeah, I think it's community driven. So as soon as I'm able to solve an issue, I will create a new test and a new repository that handles that particular problem. At the beginning, to be honest, I tried to use real world cases. So for example, I tried to download some project from Apache, and I was doing operation on Apache. The problem was that even though it's a real case scenario, so yeah, so it's real data, it was really slow, and it was hard for me to find specific cases that I wanted. So by manually creating them, I know it's not real anymore. However, I can tackle specific cases that I really want. So that's why I manually create all of them instead of just relying on existing repositories.
And PyDriller is built specifically for addressing Git repositories, but there are also other version control systems, the most notable contender being Mercurial, as well as some of the predating systems such as Subversion or CVS and some esoteric ones. I'm wondering what the level of effort would be to add support for other version control systems and what the overall utility or benefits would be if you were to try and address that case.
So there are two problems. The first one being someone needs to learn the new version control system. And at the beginning, for example, so to be honest, in PyDriller, there is a branch called, I think, Mercurial or something like this, where I already ported PyDriller for Mercurial. And the problem, though, is that I'm not an expert. I was not an expert, and I still not an expert on that. So many things. Well, I was not sure how to do it properly, and that's strange because Mercurial is written in Python, so it should be easier than Git to do, but it wasn't. So and that's one of the reasons why I haven't merged everything together. And this was already like 2 years ago. It's just that someone needs to learn it, and I was not there at the moment, and I didn't know Mercurial that well because again, this should be a framework for version control systems. So to be able to do those kind of things, you really, really need to know the mechanics of Git itself, or in this case, Mercurial. So some things were just not right. And I think now Facebook uses Mercurial. So it has been some time now that I use Mercurial. I am still not an expert, so I'm not sure whether I will actually start again and try to see again how to do those kind of things. And this is because of the second reason why I haven't done it yet is well, let's say know your audience. So most of the people uses Git, and the research studies are done on Git repositories. So me spending like, I don't know, 6 months or something like this to port PyDriller in Mercurial, it's well, the gain is gonna be really marginal here because not a lot of people are gonna use it. And Mercurial is mainly used like in industry, and I'm pretty sure that I don't have many users that come from industry. So at the time I said, well, let's just focus on Git. And now that it's becoming a bit more popular, I know PyDriller is used in a couple of companies. So Mozilla is one of them. In some of their products, they use PyDriller inside. SIG, the company where I used to work, also uses PyDriller, but still this company uses Git. So I'm not sure whether I will actually spend time on put Mercurial on it. But anyway, I think if someone wants to do it, of course, it's more than welcome. And I think, the kind of operation that PyDriller does on the repositories, as I said before, it's mainly reading. So get the list of commit, list of authors, dates, and the diff for each commit. You get the diff and the source code of the file. And that should be more or less it. So those are the kind of information that I extract from the repository. So it should be doable to do in other control systems, but I am not that much of an expert right now, so I'm not sure how complex it will really be.
And you mentioned that it has started to make its way into use within industry. And I've seen, when I was looking at the dependence graph of tools that are using PyDriller, some examples of frameworks that people are using to pull out useful code metrics for determining things like development velocity and help to provide feedback to engineering leadership to direct their colleagues in how to address some of the introductions of bugs and things like that. I'm curious what you have seen as some of the most interesting or unexpected or innovative ways that you've seen PyDriller used.
Okay, so as unexpected, I would say some time ago, I don't know how I did it, but I found an exam, a university exam, asking PyDriller questions on PyDriller inside. That was unexpected and really fun. One tool that came out just recently, I think, less than a month ago, that internally uses PyDriller. It's an amazing tool from students here in the Netherlands as well. And so what they do is they represent the repository as a graph. So, and each node is like a commit or an author or a file, and they build this graph using PyDriller, and they build this graph in Neo4j. And so after PyDriller is done and the analysis is done, you have this beautiful graph that you can query. And I mean, it's like PyDriller, but it's visual. You have something that you can see, and the queries are super fast, and you can do amazing stuff with this. So I'm really looking forward to see how this tool will evolve in the future. I think this tool is called Graph Repro, and it just came out, and it's really, really interesting. They published a paper about it, and internally they use PyDriller. So very, very happy to see that other people use PyDriller to build their own tools. And yeah, so I saw Bugzilla that internally has PyDriller as a requirement. So overall, I think I'm really happy that people just uses PyDriller to do their own research and their studies. And if we can somehow, help in building better tools, then I'm all in.
And in your experience of building the PyDriller tool and using it to help teach people about mining repositories and growing the community around it and supporting it as a maintainer, I'm wondering what you have found to be some of the most interesting or unexpected or challenging lessons that you've learned in the process.
So there are many that I learned. So this was actually my first like big open source project. It's not even that big, but let's say impactful open source project. So first of all, I learned how much Git is complicated. I didn't know, and when I presented the tool, I showed that Git has 150 primary commands like git log, git push, git add, etc. These are only one command, one at a time. But then if we look at subcommands, like git log is probably going to have like 500 subcommands or something like this. So, I mean, it's crazy how Git is complicated and how powerful the tool is. And it's crazy to see how people really know everything about Git. And I mean, I developed a Git framework and I'm not an expert, not at all, because really it's amazing to see the community around this version control system and how well they know their system. It really amazes me every time I Google something on Stack Overflow and they know everything about it. It's really awesome. So that on the Git side, let's say. On the maintainer side, well, everything was new for me, and I think something I'm still struggling with is understanding when is the limit. So as a maintainer, you are supposed to well maintain the code, right? So if someone finds a bug, you're supposed to fix it. I think more or less that's the theory. So where is the line where that you draw where like you say, okay, from this moment on, I will reply, okay, thanks for reporting the bug. Can you please fix it? So this is something I'm not sure. When I have to say it, like, is it already done? I mean, is it already that big that I can just say, please, can you fix it by yourself? Can you go in the code and fix the bug? Or should I still, fix it by myself and say, thank you for reporting it. I will work on it in the next couple of weeks. So I'm not sure. Yeah, I'm not sure that what's the role of the maintainer here. Like, yeah, when it's the point where I will just say, okay, no more bug fixing for me. If you want to fix it, you fix it by yourself. So I'm not sure. I actually Googled it and I read articles, but there is no, I think, right and wrong. It's just, well, I think at one point I will just give up and say, okay, but it is done for me. You just fix
Yeah,
it.
that's definitely one of the big unanswered questions in open source is what is your responsibility after you release something to the world, and at what point do you say I'm done with this, or this code is complete and it's not going to be touched anymore, or handing it off to a different maintainer who can then take it in new or different directions or just maintain the status quo. So it's definitely something that, as you said, is challenging, and there is no one solution. It's just whatever feels right for the person who is the progenitor of the code and has the ultimate responsibility for it.
Yeah, exactly. Definitely. There is no right and wrong. I think it's 3 years now, and I'm still fixing the bugs that are reported by the users. So that's the point. I think eventually I will just give up.
And in terms of PyDriller itself, what are some of the plans that you have for it, either in terms of fixes or improvements to the code base itself, or ways that you plan on using it for conducting your own research or building additional tooling on top of it or with it?
Yeah, so I think as features, what I see in the last year, that what I see that happened in the last year is users ask users ask for new filters. So as I said before, PyDriller has a huge amount of filters that you can filter a repository, the commits coming from a repository. So at the beginning, I started with just from a date to a date. That was it. That was the filter. But then I added from commit to commit, from tag to tag. Only in certain branches, only the commits that touches this file, or only the commits from this author. And all this was coming from users that were just saying, can I filter for author or something like that? So I think from the Git side, I think I already report everything that I can. So like the commit hash, of course, the author, the date, the diff, and the source code, and the branches. I think I report. I mean, those are the let's say the fields of a commit. Those are what can say about a commit. However, what I can actually improve in PyDriller, what we are trying to do as well as a community, is adding new features. The last one was we added the possibility to return the commits coming from all the branches, even if they are not cloned here. It's like the git log minus minus all from the terminal. And the same thing, we just did it in PyDriller. So now you have the minus minus all as well. So these kind of things, I think, well, there are so many, as I said before, Git is so big that there are so many possible commands that you can pass. And I think PyDriller will definitely increase on this. And another thing we can definitely do is put more code metrics in there. So right now, PyDriller returns, I think, the complexity of the methods and the coupling, if I remember correctly, and lines of code, something like this. But they are quite simple. We have the source code before and after the commit for each file in the commit. So I mean, we can do everything we want about it. We can see like the delta of the complexity. This was one of the last changes that someone made in PyDriller. We can really do a lot. I think it's community driven. If people need something, they can just open an issue on PyDriller, and I will be happy to help them in trying to implement it, coming to the same point as before.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose a tool. I may have picked it before. I know I did a podcast about it, but in any case, the pre-commit framework for managing pre-commit hooks in your Git repository to handle things like running linters or executing isort before you commit, all that kind of stuff, just to help reduce the cognitive overhead of having to make sure that all that gets run. Definitely a useful tool to help with maintaining the cleanliness and maintainability of your code. So definitely recommend checking that out. And so with that, I'll pass it to you, David. Do you have any picks this week?
Yeah, so I was thinking about it, and I just discovered 2 days ago, a beautiful game for PlayStation. It's called Fall Guys, and this is like a sofa game. Let's say I played with my girlfriend, so I love play PlayStation. She often watches me playing because she doesn't like those FPS games. But this game is just the best for couples. We just play one match at a time, and it's really fun, and it's a lot of laughs every time, and it's not difficult at all. And it really small games, like 30 seconds, 1 minute games. It's really, really fun. You should have a try.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you've been doing with PyDriller and your experience with mining software repositories and doing research on practices for writing code and evolving it over time. It's definitely a very interesting framework and an interesting problem domain that helps to inform the ways that we do software engineering. So thank you for all of your time and effort on that. And I hope you enjoy the rest of your day.
Thank you very much, Tobias. You too.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.